this video, we're going to talk about the triangle inequality theorem. The triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the third side. Okay, so for example, on this one, AC plus BC has to be greater than AB. So side 1 plus side 2 has to be greater than side 3. BC plus AB has to be greater than AC, and AC plus AB has to be greater than BC. The relation of the side lengths and angles. The smallest length corresponds to the smallest angle. So if you take the smallest length and go straight across, that's the smallest angle. The middle length or the medium length corresponds to the medium angle, and the largest length corresponds to the largest angle. So on this one, we're going to list the sides in order from shortest to longest. Okay, so the first thing that we have to do is find this missing angle right here. Okay, so the first thing that we have to do is know that a triangle adds up to 180. So first, we're going to take 49 and we're going to add it to 60. And that's going to give us 109. And then we're going to take 109, we're going to subtract it from 180, and that's going to give us 71. So this is 71 degrees. So it says list it from shortest to longest. So shortest is 49, and then 60, and then 71. So we want to list the corresponding side lengths. Okay, 49 is first, so our first side length would be NP. That's the smallest one. The next one would be across from 60, so that is NP, and then the largest one is across from 71, so that one is NM. So those are from shortest to longest. Okay, the same thing right here. First we've got to find our missing side. Okay, 36 plus 64 is 100, and 180 minus 100 is 80. So our angles then in order are 36, 64, and 80. So across from 36 is AC, across from 64 is BA, and across from 80 is BC. Okay, so those are listed in order. Now we want to list the angles in order from smallest to largest. So now we're going to, given the side length, we're going to go the opposite way. So looking at this, our smallest side length is 16. So it's 16, and then 22, and then 28. So across from 16 is angle J. Across from 22, is angle G. And across from 28 is angle H. So those are listed in order. Here, our side lengths from smallest to largest are 2.1, 2.2, and 2.5. So across from 2.1 is angle T. Across from 2.2 is angle U. And across from 2.5 is angle S. Okay, the range of possibilities states that if you're given two lengths of a triangle, to get the range of the possible lengths of the other sides, you want to add the sides together and then subtract the highest from the lowest, and that's going to give you your range. So for example, if I have a triangle and I have side lengths of 12 and 7, okay, I want to know what my possible side lengths here. So I would take 12 plus 7, which is 19, and then highest from lowest, so I take 12 minus 7, which is 5. Okay, and so my side lengths are in between 5 and 19. Okay, they can't be 5 and they can't be 19. It has to be in between there. So the way we would write that would be that T has to be greater than 5 and less than 19. Okay, so the side length for this can be anywhere in between there. Okay, in order to do this one now, okay, so this is saying that we've given this, so we have this here. So we have 25 and 9. Okay, so we're going to take 25 plus 9, and that's going to give us 34. And then we're going to take 25 minus 9, that's going to give us 16. Okay, so our possible lengths then for the third side would be the third side has to be greater than 16, but less than 34. Okay, greater than the smallest number, less than the biggest number. So on this one now we're going to take 11 plus 20, and that's going to give us 31. And then we're subtracting the biggest from the smallest. So here we have to say 20 minus 11, and that's going to give us 9. So the third side has to be greater than 9 meters and less than 31 meters. On this one, we want to state whether each described triangle is possible. Okay, so what we want to do is we want to figure out if, when we add the two of the sides together, if it's greater than the third side. Okay, so on this one, we're going to take 11 plus 4, and we're going to see if it's greater than 15. Okay, 11 plus 4 is 15. Okay, now 15 is not greater than 15. It's equal to 15. So we know that no, this one can't be a possible triangle. Okay. On this one, okay, well, when we're adding up all the sides here, 21 plus 24 is greater than 7. Now we know that's true, right? That's one that 21 is greater than 7, right? So anything you add to it's going to be greater than 7. But anyways, just to finish it out, that would be 45. So 45 is greater than 7. That's true. Okay, now we want to do 21 plus 7 right here. We want to see if it's greater than 4. Sorry, greater than 24. Okay, so that would be 28 is greater than 24. Okay, and then 24 plus 7 needs to be greater than 21. Okay. Okay, and 31 is greater than 21. Now, a fast way to do this is you actually don't have to check all three sides. All you have to do is just pick the two smallest side lengths. In that case, that would be 21 and 7, this bottom one right here. Okay, 21 and 7, and it has to be greater than 24. So 21 plus 7 was 28 is greater than 24. Okay, that's the only one that you have to check. If that one's true, then you know the other two true because they're bigger numbers. There's going to be a smaller number left on the other side. Okay, so the same thing on this one. If we had checked the other sides first, we would have found two true statements. But in this one, we did check 11 and 4 were the two smallest sides. So 11 plus 4, 15 was not greater than 15. So this one was no, and this one was yes. It could be a possible triangle. And that's the end of triangle inequality theorem.